Going to clean up here on levels of measurement by talking about variables that have only two values. I've changed this from the last video. I've added two new variables in place of, I think it was student ID. Each of these are what's known as dichotomous, which means they only have two. Dichotomous variables have only two categories, and I'm defining them here. G is gender, and V is vote choice, let's say from the 2012 general election, presidential election. Scored 1 if the person voted for Romney, and 0 if the person voted for Obama. You can switch those. Gender scored 1 for female and 0 for male. I'll make later a problem, work through a problem that actually includes these hypothetical variables and hypothetical values of the variables. I want to finish with levels of measurement in reference to this kind of variable, because these are very, very special. As long as they're scored 0 and 1, you would mess things up if you had a binary, sometimes called a binary or a dummy variable, dichotomous variable, sometimes called bits. It would mess them up if you scored them 11 and 17. Scored as 0 and 1s, they are bits, the little things that make computers work, strings of zeros and ones that make computers work. And they have some other fascinating, very simple, very elegant properties, and we'll work with them both on video and in class, often, binary variables. I'm going to wonder if these two things are related, gender and vote choice, and I'm going to explore a hypothetical problem a little bit later that focuses on just that, referencing probability. There's a little simple probability presentation. This is just a translation of it. This is the probability that vote, V sub I, equals 1, given, remember that sign, given that gender equals 0, or otherwise given that we're focusing only on males, and alternatively the probability that V equals 1, given that gender equal female. If both of these things simultaneously simplify to the probability that VI equals 1, then those two variables are independent. And we're going to look at a very, very general and very powerful way to explore that inferentially with a hypothetical small data set in not too many videos to come. These are extraordinarily simple and extraordinarily easy to work with, and got the trusty quickie, and we can dummy the most difficult variable level of measurement to work with, which is the nominal level. I gave you the example in the previous video. One of the examples of the nominal level of measurement is religion. So we'll call it R sub I. And probably put it up over here, right? And religion, we'll give it 5 categories. Christian, and let me see what I did here. Catholic. Call it Catholic, Protestant, Jewish, Islamic, and the catch-all category of other. An illustration here of something relative to measurement that's actually quite important. The categories here have two really, really important properties. They are mutually exclusive, or I'm going to call them that, mutually exclusive. Or they're going to be mutually exclusive when I'm, at least when I require respondents to a survey to choose one and only one of those categories. And they are exhaustive. Just a little more vocabulary of measurement here. Mutually exclusive categories and exhaustive categories. I'm assuming that nobody who is Jewish is also Christian. That's a stupid assumption. But for measurement terms, a scale has categories that are mutually exclusive and exhaustive. It's going to relate very closely to the next topic, which is about measurement theory, measurement validity, measurement issues much more generally. So we'll come back to that, but let's just score these up with numbers. So this is 1, 2, 3, 4, and the exhaustive category other. Let's just bring in almost everybody else. That's a hard variable to work with statistically, just as it sits, because again, the definition of the nominal level of measurement is that these numbers don't mean anything except they distinguish one category from all the others. Other is not 5 times Catholic. Islamic is not 5 times Protestant, not twice otherwise, Protestant, and so forth. But we can easily, through manipulation, make them into what we just saw, the dichotomous binary binary variable, a dummy variable, by doing the following. So we're going to create 5 new variables. I'm going to call this one di1, di2, di3, di4, and di5, d for dummy. I'm going to make this equal 1 if f means if and only if. I'm going to make this one equal to 1 if r I equals 1. Otherwise 0. I'm going to make this one equal to 1 if Ri is equal to 2, and so on. So I've taken one variable that is a multi-category nominal measure, very difficult to work with, and I've made it into 5. I've made it into 5, and if you sum across the sum of the di's, if you sum across all of these, the result is 1. Because again, they're mutually exclusive and exhaustive categories, so each individual can choose in the survey to identify, correctly or incorrectly, themselves as only one of these religious persuasions. And so, create these 5 new variables that are dichotomous, and probabilistically they work just exactly like the ones that we looked at over here, G and V, gender and vote choice. Now I've got 5 here. So a baseline, probably my favorite here. Intellectually, conceptually, what does it mean? My favorite here might be number 5, which distinguishes other from all the rest. Again, you sum up all of these and you find 1. So you sum up DI 1, 2, 3, 4, 5. One of them, and only one of them, in each ith case equals 1, so the sum by definition is 1 plus 4 other zeros. Toward the end of the term, toward the end of the video series, we're going to start working with these quite extensively inside the context of regression models. Last comment on levels of measurement and dichotomous variables or binary variables or dummy variables, bits. Very often these things are distinguishing the presence or the absence of something. So I got down to the absolute level of measurement and demanded that it have a genuine 0, showing the absence of something. Demanded that it have an invariant scale, so that you sort of change the meaning if you multiplied it by a number across every observation. Many dichotomous variables are absolute measures and presented very often in textbooks as nominal level measures, and in fact they're not. These are assuming we have mutually and exclusive mutually exclusive and exhaustive categories, that is, assuming away the prospect of anybody transgender being in the sample, we have only male and only female, we have mutual exclusivity and exhaustiveness, then we are really here looking at the presence or the absence of one of the other genders. They are ordered, so they are ordinal. They're ordered no matter how you flip them. 0 to 1 indicates if 1 is equal to female, increasing amount of femaleness, if that's a word. If flip it and it's the same thing. These very unique variables, the ones that have 2 and only 2 categories and are scored only with a 0 and only with a 1, these have all of the attributes and sort of the levels of measurement, and are sort of indicative of a deeper issue, a deeper topic, and one that really is the subject of present sort of philosophical debate about levels of measurement. Some of them don't fit in that original scheme as neatly as the others. These binary variables, whether they're independent or dependent, are of that nature. They're kind of a little bit of everything. That is, assuming they're measured correctly. By correctly, I mean valid measurement and reliable measurement, and those are topics that are the subject of the next video: measurement validity, measurement reliability, and other topics in measurement theory. That's it for now.